So hello future achievers, in the last class we have seen how to do the error analysis and we have solved a lot of examples also. In today's class we will also do one question and then we proceed for the vernier caliper and then we go for the screw gauge and finally our chapter will be completed. So let us start with the one numerical. The numerical is given that there is a one like you can consider a well is there and we are dropping a stone from this point and it's take a time t1 and it's reach the bottom and then from bottom the sound is coming, okay, and the sound is coming and it take a time t2. The error in the total time is given as 0.1 second and the length is given as 20 meter. The g value is 10 meter per second square, that means there is no error in g, and the error in sound is given as 300 meter per second. You have to calculate the percentage error in length. Then how to approach this type of question? The first you have to see how to calculate my t1. Okay, so you know the basic law of second law of equation, that is s is equal to ut plus half d square. As it is dropped from here, so initial velocity will be 0. So from initial velocity 0, so I will get my total like what is the time taken from the stone to from this point to reach to this point, that will be my 2 seconds. Okay, as I know this time, after that I have to calculate my another time t2. Now how to calculate another time t2? So the sound is coming from here to here, so that means my time t2 will be L by Vs. So my distance is what, 20, and my speed is 300 meter per second. So from here I will get my time t2. Now my total time will be t1 plus t2. So my this expression I can write like this. Okay. Then after that I will apply the formula for percentage error, and you will when you will apply, you will guess this 1 by 2 into delta L by L plus there is no error in g. So obviously this term will become 0. Then we have a delta L by L, this error, and there is no error in speed of sound also, this will also become 0. So by t1 we will get, but t1 is basically this thing. So from here I can apply the propagation of error here also. So it will get delta t1 by t1 is equal to 1 by 2 of delta L by L. Now if I calculate delta t1, what is my delta t1 will become? It will be 1 by 2 into delta L by L into what is my t1? T1 is my 2 seconds. So this will become my delta L by L into delta t1. Okay. Similarly, you have my t2 is equal to how much? That is L by Vs. So can you tell me what is delta t2 by t2? That will be equal to delta L by L. Yes or no? Because there is no error in velocity of sound. Clear or not? Because delta t2 by t2 will be equal to delta L by L. So from here I can find my delta t2 will be equal to delta L by L into what is my t2? T2 time is given as 1 by 15. Now you just add these two terms. Why I am adding these two terms? What is the need? Because my total error is given as 0.1 second. So if I add, how much I will get? I will get delta L, I will get delta L by L is equal to 1 plus 1 by 15, that is 16 by 50. Is equal to 0.1 second. Clear? So from here I will get my delta L by L as 15 by 16 into 0.1 into 100, because I want to calculate the percentage. So percentage, if I calculate, I will get how much? It will become 150 by 16. That value will be how much? 2 7 14 and 10, then 8, just 64. No. .1% almost. So this is the how you have to like apply the approach. Okay, so it basically involve complete like this type of question generally you can expect in some good examination, some like some IIT or some mains questions. You can also accept this type of question. In NEET they will generally ask this type of question, which we have covered in the last class. So this type of question come in NEET examination, and this type of question generally they ask in the IIT or JEE question. It is basically a previous year of some previous year question of I think JEE only, and this is a previous year question of NEET only. So basically you can see we are practicing both the types of questions so that you can prepare, get the those who are preparing for NEET, they can solve this type of question, and they can practice themselves, and those who are preparing for JEE, they also get an approach how to solve the JEE questions. Okay. Now next, let's proceed further, and next let's start. Most important thing is that vernier caliper. See, first I will make very important thing clear. For NEET point of view, the vernier caliper and skew gauge are not that much important, but if you want, you can study. And for JEE and for JEE or advanced point of view, it is very important. There is a very important questions are generally asked from this topic. So those who are preparing for NEET, they can just read it. But if I am going in detail, so for them it is not required to go in detail. They just know the basic formulas, how to calculate least count, and just only that much is important for the NEET student. Okay, let's start. So this is basically my vernier caliper. I hope it is visible. Yeah, so you can see like this scale. You are seeing this scale. Oh, sorry. You are seeing this scale. This scale where there is a markings are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This markings. This is called as a main scale. Okay. This is my main scale. This is my main scale. Where you can see the markings are there. This is my main scale. Okay. This is the main scale. Okay. Let me write properly. It is, maybe it is not visible. Okay. This is my main scale. Okay. This is my main scale where there are markings are there. Okay. You can see here there is a one small scale is there. This is small scale is called as a vernier scale. Okay, this is small scale is called as a vernier scale. These are called as a jaws. Basically, inside this only we keep the any instrument which we want to measure, and then measure the length and all those things. Okay, for holding, they are used for holdings. For holding. Okay, and this for the inner jaw, they are used to measure the inner diameters of a, like they are the also jaw, they are also used for holding, but they are used to measure the inner diameter of a cylinder, like these things. This is called as a strip. It is used to measure the depth. Okay, measure the height, you can say. Suppose a cylinder is there, you want to measure the height, so you will use this. Clear? In our syllabus, we have only two things to read. First, what is the thing we have to read? In our syllabus, if you see, we have only two things, and that are, we have only two things to read in our syllabus. Okay. So in our syllabus, what we have to read? We have to read only two things. The first thing we have to read is the how to measure the length. How to measure the length. Okay, by using the vernier caliper. That is the first calculation we have to do. Second is how to measure the diameters. Second thing, how to measure the diameter. Okay, so that is a two calculations we have to see here. Lot of other things we can also measure, but in our syllabus we have to, like we can measure other inner radius, outer radius, everything we can measure. but in our syllabus we have to deal with this much only. Okay, so we have to study these two things only. So this is the picture, you have to be very clear. Okay, this is the picture of vernier caliper, these are the components are there, and this is the two things we have to see. Okay, now first thing we have to learn about is the what is called as a least count. Okay, first thing we have to learn is what is called as a least count. Then we can go for any further measurement or anything other. First we have to understand what is the least count. Clear? So let us understand what is the least count. Okay, see, if you see clearly, I just copy this image once. Let me copy this clone. Okay. See, if you see this image clearly, what you can see, let me for you zoom. Okay. Wait. Yeah. Let me do the one thing. Okay, if you see properly here, you can notice one thing. What you can notice from here, I think it is visible or not. I think it is not visible. Let me make it more visible. I hope it is now visible. Yeah. If you see here properly, what you can see, now you see here, now you will understand. See, you can see here, okay, like this is the 0 of the vernier scale, na? This is the 0 of the vernier scale, and this is the this is the 0 of the vernier scale, and this is the and this is the 0 of the this this is the 0 of the main scale, and this is the 0 of the vernier scale. Okay, these are the two scales are there. One thing you can see here, that is, if you see how many number of lines are there in the vernier scale, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there are total 9 lines are there. Okay, now let's measure in vernier scale. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we have seen, my main scale division is less than the vernier scale divisions. Sorry, my main scale division are more than the vernier scale division. Means, if you see here, suppose this is my 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 lines are there between these two. Okay, between these 2 points, in one unit we have a 10 lines, but in the vernier scale, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 lines. Sorry, what we have? Oh, sorry. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 lines. We have a 9 line. Means we can say in 1 centimeter. Suppose because meter scale in centimeter. So in 1 centimeter we have basically 10 lines in main scale. But in vernier scale, within those 10 lines or 10 divisions, we have only 9 divisions. So I can say what 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we have understand from there? Let me draw, then you will explain better. This image is not sufficient, I think so. For your reference I am keeping this image, but let me draw by myself. Okay, then it will be more clear. Suppose this is my main scale, okay, and this is my vernier scale. Okay, suppose these two scales are there. Okay, suppose these two scales are there. Suppose there are these two scales. This is my main scale. This is my main scale. And this is my vernier scale. Okay, and suppose, let's one minute. हेलो 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 बाबू, देखना आ गया है मोबाइल पे। हेलो, हाँ हाँ जी, चेक कर रहे हैं। जी हाँ, आया है। बैठा चेक कर रहे सर। हाँ जी, आ गया ना? जी जी जी, ठीक जी। पापा को बता देना। जी जी, मैं बता दूंगा पापा को। हेलो, अरे पापा, आप 15 क्यों भेजे हैं? 15,000। हाँ हाँ, वही कह रहे हैं, 15 क्यों भेजे हैं? बट अरे 1 महीना रहना है ना वहाँ से। अरे 1 महीना रहना है तो इतना भी थोड़ी ना महंगा है। चलो रखो, ठीक है। हाँ, बाहर रहना है, पैसा रहना चाहिए ना, जानते हैं, हर चीज करके मिलता है। ठीक है चलो। Yeah, what I am telling, see, let's see here. Sorry, let's see here. See, if you see 1 2 3 4 5 6 7 8 9 10, we have total 10 lines are there. Okay, total 10 lines in one main scale. In one main scale we have a 10 lines. Let me draw here, that will be more clear in spite of showing this in image. Suppose this is my suppose this is my 1 2 3. Basically what I am trying to say, suppose यार 3 5 6 7 8 9 10 then 1 2 3. अरे यार yeah, let's see here. So you can see the number of divisions on the main scale is basically less than as compared to the number of divisions in vernier scale. Generally what is going to be happen, see first let me write the least count, then you will understand. Least count is basically one main scale division minus one vernier scale divisions. Okay, now if you see properly, what you will find, see this least count has to be always positive. That means the number of divisions on main scale will be always more than the number of divisions on vernier scale. Okay, it will be always more than the number of divisions on vernier scale. Generally you will see that is general condition, is number of divisions on MSD is more than VS, means number of divisions on main scale is generally more than the number of divisions in vernier scale. Okay, if you see here in this scale, you will find that this is my if you see here, there is 0 1 2 3 4 5 6 7 8 9 10, total 10 main scale division is equal to how much in vernier scale? 0 1 2 3 4 5 6 7 8 9. It is equal to 9 vernier scale division. Okay, so 10 main scale division is equal to 9 vernier scale division. So my main scale division is basically, if we see in main scale for 1 centimeter, it is for 1 centimeter we have 10 lines. Between that we have 10 lines now, so this will become 0.1 centimeter. That is the least count of main scale division, one main scale division. That is my one main scale division. Now what is vernier scale division? See, you can't calculate the vernier scale division because there is no reading is there. So what we will going to do, we will say it is 9 by 10 of main scale division, correct or not, from here. So from here what I can say, it is 0.9 by 10 of centimeter. So my least count will be how much? One main scale division minus vernier scale division, na. So from here we get this value. If you subtract, you will get 0.01 centimeter. So that is the least count of the vernier scale. It is a general case. This is a general case. So you have, what you have to remember? You have to remember this formula. You have to remember this formula. This formula is the basic general formula. This formula is a general formula. You have to remember this formula only. Okay, this formula is your general formula. Generally the least count of a, if nothing is mentioned in the question, generally the least count will be taken as 0.01 centimeter for a vernier caliper. But the method is, I explain you what is the method. You have to see how many main scale division is equal to the vernier scale division, and generally you will find that my main scale divisions are more than the vernier scale. Okay, means main scale is bigger than the vernier scale, that you will find. So from here you will do these calculations and then you will get the least count. Okay, suppose I got the least count. Now how to, suppose let's take one example, then we will better clear how to calculate a least count. Let's take one example. Suppose there is a one question is there. The question says, in vernier scale, in vernier caliper, the main scale is marked in centimeter and 20 vernier scale divisions is equal to 16 main scale divisions. So calculate the least count, and remember 1 MSD is equal to 0.1 centimeter. Then how will you solve? It's very simple. What you have to do? See, least count is 1 MSD minus 1 VSD. Clear? What is the relation is given? 20 VSD equal to 16 MSD. That 16 main scale division. So from here I will get my vernier scale division as 16 by 20 main scale divisions. So when I get my this relation, I can directly put it here and I will calculate my least count. That is, least count will be equal to how much? 1 main scale division minus 1 vernier scale division. So this will be 1 minus 16 by 20 into main scale division, and this is equal to how much? 4 by 20 into 0.1 centimeter. So from here I will get this value as how much? 1 by 5 into 0.1. That means how much? 0.02 centimeter. So you have seen, see, I have taken another relation, so my least count will be changed. So that's why you have to remember this general formula. This is my general formula which you have to remember. Okay, you have to follow this formula. Clear? You have to follow this formula. Okay, don't remember anything else. Just a student used to remember that number of main scale division minus, it can be changed. Okay, it can be changed. So you have to remember this formula. This is a general formula, and then you have to see what is the question is saying. On the basis of that you have to calculate the least count. Okay, now let's see one more example. For NEET student, this much is important. This much is only, this much they will going to ask. No, not further they are going to ask. Okay, that much is important. Okay, just give me 1 minute. Okay, let's take one more example. Okay, it is given that n divisions on main scale equal to, are equal to n plus 1 divisions on of vernier scale. Vernier scale, if each division on main scale is a unit, then least count is how much? You have to calculate the least count. So what you will do, least count is 1 MSD minus 1 VSD, correct? Least count will be 1 MSD minus, least count will be 1 MSD minus 1 VSD. So what is my one main scale division? One main scale division that we know, that is a unit. What is my vernier scale division? We use this relation because n division of the main scale is equal to the n plus 1 division of the vernier scale. So what is the relation we got? We got n divisions, n male scale divisions is equal to n plus 1 vernier scale divisions, correct or not? N main scale divisions is equal to the n plus 1 vernier scale division from this relation. So from this I can say my what is VSD, vernier scale division, is equal to n upon n plus 1 main scale division, correct? Just put this value here, what you will get? My least count is equal to MSD into 1 minus n upon n plus 1. So from here if you put this value of MSD is A upon n plus 1, that is my least count answer. Clear? So they both are the previous year questions. So basically this is how we find the least count of a, I hope now you are familiar how to find the least count of a vernier scale. That is very easy. Always you have to see what, how many, just you have to remember this formula, that is least count is 1 main scale division minus 1 vernier scale division. The smallest thing you can measure is that is only the least count, and that is main scale division reading minus vernier scale divisions. And for calculating the you have to find the second thing, you have to find the relation. When you will get the relation, you can directly calculate the other things which is required. Clear? That is not a problem. Now next thing, how to take the reading. Okay, till now we have understand how to measure the length. Now the next thing is that how to take the reading. Okay, let's see. 1 minute. I think I cannot bring it to the next page. Okay, let me import this much and download. Okay, yeah, so let's see how to do the measurement with this. Okay, now how to do the measurement. That is our next approach. How to do the measurement. Clear? See, first you should know how to calculate the least count. You went to the experiment lab, you calculated the least count. Okay sir, this is the least count. Now we have to do the measurement. So how will you do the measurement? Then let's see. See, the first thing is that total reading. First understand this. Total reading is equal to main scale reading MSR plus vernier scale reading, and that is equal to least count into coinciding division of main scale with of vernier scale of vernier scale with main scale. That is the thing you have to write. So basically what you have to do, just let me explain you with diagram. Okay, I will erase the diagram after that. Suppose this is my main scale and these are the readings. Suppose this is 1, then 1 2 3 4, 1 2 3 4, then we have 5, then we have 6 7 8 and 9, and then 10, then we have a 2. Okay, and after that suppose there is my vernier scale and this is 0 1 2 3 4 5 7 8 9. Okay, so this is my vernier scale and this is the vernier scale. So suppose you have keep some suppose you have keep something between these jaws. Okay, and my vernier scale, suppose you have keep something between the jaws. Okay, so my vernier scale will move backward, obviously, because if you keep something here it will move backward. Suppose my vernier scale is like this now. Okay, this will be my vernier scale, suppose. Okay, this point is suppose 5 and this point is suppose 6, and my object is somewhere like, okay, it is like this, and this is my readings on vernier scale, something like this readings are there. Okay, some readings are there over vernier scale. So now how to do the measurement, sir? How we can measure? Okay, first what you have to do, what is visible from this, you directly write out from the main scale. See, this is 5, this is 5 to me. Okay, I written, that is my main scale reading. Now what is my vernier scale reading? Least count. What is the least count? Least count we have calculated generally, that is 0.1 centimeter into what is the coinciding division of the vernier scale with main scale. Which division is getting coincide? Just see here, this is my 0 1 2 3 4 5. See, fifth division is coinciding, so you have to multiply it with 5. So this will become 5.6 plus 0.05. So that is my total length is 5.65 centimeter. Clear? So that is how we calculate. Any doubt? We will do some example, then it will be more clear. Okay, we will do some example. Till now, so that is how we are going to measure the length of any, or do the measurement in the vernier scale. Let's see it. Let's see one example, then we will understand it. Okay. Okay. Remember, they don't remember the formulas as it is. Okay, just you have to understand the concept behind this formula, like how it is coming. Okay, if you are just mugging the formulas and you are thinking that you can solve the question of error analysis, so it is very difficult. You have to understand the concept properly. That's why I am going in so much detail. Otherwise I can finish off in like in one line, just because it is very small topic. There is 2 formulas are there in just topic and nothing is else there. But why we are going in so much of detail? Because we want to understand each and everything to do the calculation. Because in the question they will not directly give the value. Just put the value and apply the formula. No, they will never go do this. Okay, so just you have to be very much like you have to very much clear regarding everything. Then only you can solve any question. Okay, let's take one example. Till here, anyone have any doubt? Please tell me. You should know how to do the proper reading. Okay, let's take one example. Suppose the diameter, okay, the diameter of a cylinder measured using a measured using a vernier caliper, with zero error, with no zero error. What is zero error? We will tell you first. It's very easy thing only. Okay, with no zero error. Just leave that line. Okay, with no zero error, it is found that the zero of the vernier scale, the zero of the vernier scale lies between 5.1 centimeter and 5.15 centimeter of the main scale. Okay. And the vernier scale has total 50 divisions, equal to 2.45 centimeter, equal to 2.45 centimeter. The 24th division of the vernier scale, the 24th division of vernier scale exactly coincide with one of the main scale, with one of the main scale. Okay. Main scale division, then determine the diameter of the cylinder. Okay, that is a question. Now you have to solve. If you want, I can give the options also. Let's give the options. Okay, so it will look like suppose the option A is 5.112 centimeter, option B is 5.128 centimeter, option C is 5.134 centimeter, and option D is, actually there is a screen, so I am writing the question there from there only. It is 5.148 centimeter, because I cannot remember the questions. I can remember the concepts only, I cannot remember the questions now. Okay, so you have to solve and you have to tell what is the exact length of the basically diameter of the cylinder. Okay, now those students who are thinking I can directly apply the formula and get the answer, they cannot apply the formula and get the answer, because this is the exact, this is the, see, NEET only asks up to this much. Okay, they generally ask about the least count, how to calculate least count. This is for NEET. Okay, that much is for NEET. Now I am talking about here, from here I am talking about JEE student, and this is especially for JEE Advanced. It is one of the previous year of question of JEE Advanced. Now let's see here. So for NEET student, if they don't want to do, don't do it. They are not going to ask any type of this type of question. Okay. Now for for JEE, let's think how to solve this, because if you know the formula also, then you cannot solve, because there is no similarity between the main scale division and vernier scale division. How to solve this? Okay, so let's read the question line by line and understand it. What is the question is saying? The diameter of the cylinder is measured using a vernier caliper. Okay, the diameter of the cylinder. Okay, we are using vernier caliper to measure it. Okay, no issue. With no zero error. Okay, what is that no zero error? Okay, I don't understand, let's leave it. Next, go to the next line, no problem. It is found that the zero of the vernier scale lies between the 5.10 centimeter and 5.15 centimeter. Okay, from this line what you understand? See, this is my main scale and this is my vernier scale. Okay, let's see here, let's go to the next page. See, this is my main scale and this is my vernier scale, correct? There are the divisions on the main scale, and suppose this division is 5.10 centimeter and this division is my 5.15 centimeter, correct? And my vernier scale is between these two divisions, yes or no? My vernier scale is between these two divisions, na? That means from this I can tell the least count of my MSD, main scale, yes or no? Because the two divisions I know, this smallest thing is only this thing, this smallest thing is only my main scale least count, na? So that I know from this point. So can I directly tell the difference is going to be the least count only, na? So from here, from this line, what is that line? From this line, from this line I can tell the least count of my main scale. From this line I can tell the least count of my main scale. So from here, so my least count of main scale will be how much? See, 5.15 minus 5.10, okay, minus 5.10 centimeter. How much this will be? You will get 0.05 centimeter. So that is the least count of the main scale, or you can say it is my one main scale division. Okay, nice, we got the one thing. Now the next thing, let's figure out. अरे क्या बकचोदी हो गई है। So that is my main scale division. I got 1 MSD. Now we have to find 1 VSD, then only we can calculate the least count. Now let us read again. Now it is given that vernier scale has 50 division, which is equal to the 2.5 centimeter. So it is saying my 50 division, not 20, the 50 division of vernier scale is equal to 2.45. So can I say my 1 VSD, that is vernier scale division, yes, it should be equal to 2.45 divided by 50 centimeter, yes or no? First tell me whether it is not correct or not. Array, 50 division of vernier scale is equal to 2.45 centimeters. So from there I can say my one vernier scale division will be equal to 2.45 by 50 centimeter or not. It's normal unitary method. So if I am saying this thing, so can I say from here what is the my vernier one vernier scale division? This will be equal to 5420 and 5940. So this is 0.45 centimeter. Yes or no? I am correct or not? Oh sorry, 0.045 centimeter. Clear? That is my this value. Okay, I got the vernier scale, main scale division. So can I tell my least count? Yes. What is my least count? One main scale division minus one vernier scale division. So this value will be how much? This is 0.05 minus 0.045. So this value will become how much? 10.5 or 0, 0, 0. So 0.005 centimeter. Is it correct or I did something wrong? Oh sorry. Let us write this 0.05 and minus 0.045. 0 correct one na. It will be 0.005 centimeter. So that is the least count I got. Clear? So that is the least count I got. I got the least count. Now my next thing is what is mentioned. The 24th division of the vernier scale exactly coincide with the main scale division. Then determine. Okay. Now the next thing is very easy. See what is the reading. We know my reading will be. What is my main scale reading? My main scale reading is, if you remember the initial line, it is between 5.1 to 5.15. So my main scale reading plus vernier scale reading, correct? What is my main scale reading is there? It is 5.10 centimeter plus what is my vernier scale reading? It is least count. What is the least count we got? That is 0.005 into what is the which division is going to coincide? That is given as 24th division. So what is the value we will get? 5.10 centimeter plus this value is how much? 0.05 into 24, that is 0.12. So this value we will get how much? 5.22 centimeter. Which option? None of the option is matching. We have did something wrong. We have did something wrong. 0.05 minus 0.045. .45. Oh sorry, this is the mistake na. This is 9 na. You should tell me. You are not telling me. 0.04. Sir, you are writing in the blackboard. How we can tell you? How we can tell you? Okay. 0.049 centimeter. Okay, so this will be 49 centimeter. Okay, so this will become 0.01 centimeter. Okay, then this will become how much? 4 centimeter. Correct? Is there is any option is there? 5.12. Oh sorry, this is 4 not 8. This is 4. So this, my correct option is option B. Clear? So this type of questions will come in the exam for JEE point of view. For NEET point of view, it is very easy. You can easily solve the question if you have a formula and you have a basic concept. But for NEET JEE point of view, this type of question will come into the exam. You have to be ready for this type of questions. Okay.